Hey guys, just testing audio. How do I sound okay? Hey, can you hear me okay?
Yes, we can hear you.
Okay, good. That's nice. Good to know. So I was just setting up and turning around to see you guys. Just a minute. Okay. So there is somebody dialed in on the phone, 8074. That must be Srini, I guess.
Yeah. I am on the phone and I'll be onto the computer in a few.
Okay, no worries, no worries. So I think you're probably leaving the office or something, or I don't know what. But it's okay. It's totally fine. You should also see me.
Yeah.
You should also see me, right? And I'm kind of looking very dark. Is it too dark here? I guess. So let me add some light, and that should address that. So you should now see me okay, and you should be able to hear me okay. And just testing one more thing before we proceed, and that is this way of toggling. So I know you have asked me to change the screen whenever I show you something. And so what I would like to do is to remind you that, that I should, if you see something that I need to maybe show you full screen like this versus the other way, which is like this, you should tell me to switch, and I can very comfortably switch. So I want to go back to the full screen like this, or you want to see me, that is also possible. So we have both options. You need to just remind me if I forget to switch. Just remind me, and I will switch. I know this is new to me, so I tend to forget, and I hope not to forget. But sometimes you need to see the full screen. So just tell me that I need to see full screen. Please expand, and I will do that, just like this. Okay. So the last time we were talking about this company called Netflix and how it is evolving. And we discussed quite a bit, but not really completely, as to what it takes to take a company like Netflix and construct it piece by piece, all the elements that we want to be able to do in the context of a cloud. So we began discussing things like the company itself, the places where it gets the videos or movies, or basically I will generally call it content. It gets the content from some source and then it delivers it to the user, the destination, which is user, which is basically people like you and me. Well, I don't watch Netflix, that's a different story, but I should. Maybe it's a good thing. Maybe I should. The idea behind these users, the destination, which is the target devices, are the devices that we have. So we studied briefly about what are the needs on the side of the devices. We discussed things like the resolution or the form factor being 4 by 3 sometimes it is 16 by 9, sometimes it is 16 by 10, and just odd sizes of form factors and shapes and sizes. And you saw that in a resolution map, desktop resolution sizes. So you have seen that variety. This picture actually shows quite a bit in terms of the level of variety available in the industry as to how various sizes and ratios of screen on the target side can vary from a plethora of the basic minimum old style telephones was this 320 by 200 all the way to 4K displays. That's what we are dealing with these days, and that's what is available in the market. Right? That's the problem that Netflix needs to solve, is somehow reach these devices at a variety of form factor, variety of screen resolution sizes, and also codecs. We need to have address the need of a codec for audio, codec for video, and these need to be transported all the way from the sources to the destination. That's primarily what Netflix pipeline looks like. And in the process, they need to also worry about one big uncertainty, really big uncertainty. And that uncertainty, or in other words, risk, is called the internet. They have to use perhaps the most unreliable method of connection. Literally, the most unreliable method of connection is the internet. Between point A, which is the sources, all the way through Netflix, through and through to the destinations that we are looking at, all of these connections are very risky in terms of the stability, in terms of the bandwidth, in terms of the availability. You know that things will go down when you absolutely don't want things to go down, they will go down. And that is also known as the law, or also known as Murphy's Law. You may have heard of this. So Murphy will strike, you know it, you know him. I know him personally, apparently. He strikes on me every single time. So to address those situations, Netflix has a full-blown open source library, or now it's called a open source center, which is dedicated to solving reliability and availability problems on the internet and also in the cloud. So here is open source software center dedicated to the open source by Netflix. And they have created tons and tons of tools to enable a variety of scenarios. And so here is a link for you guys. I'm just pasting it in Slack chat, which is right here. And the idea is that this is just one company developing quite a beautiful set of software for every aspect of making sure that they are using the cloud computing infrastructure as well as the internet connectivity all over in the best possible way, and being able to continue to provide a good video watching experience, good movie watching experience to the end users, even though we know that the internet is by definition highly unreliable. You know, things, when you don't want to go wrong, they will go wrong. And same is with any kind of computer hardware, which is, it will break. I can guarantee that something will definitely break at some point in time. That is almost universally known. Everybody knows that computers will go bad. Disks will die. Your CPUs will stop functioning. And that happens all the time. In fact, to you have run into this, I have run into this, and especially so when you're dealing with a critical problem. And so one example of a tool set that is that developed by Netflix is called Chaos Monkey. Its name is literally Chaos Monkey, and it's a part of the Simian Army tool set. Simian stands for monkeys, basically. Simian is you have this bovine. Bovine stands for cows. Feline stands for cats. Like that, Simian stands for monkeys. And so they have created a collection of tools called Simian Army, and one of them is this Chaos Monkey tool, and a janitor monkey, and a conformity monkey. And let us quickly see what these monkeys actually do. And so what Chaos Monkey really does is, imagine an example of a large deployment of bunch of huge collection of hundreds and thousands of machines that Netflix will have on the Amazon cloud doing certain operations, and we will see them. But I'm just mentioning this tool as a reference for you to remember that even though Netflix has decided and it has been running on the internet, on the cloud, on the Amazon cloud for many, many years, they have done a great deal of work to make sure that the cloud that they use actually remains in their control and that it performs exactly the way they want. And that this monkey, or Chaos Monkey to be specific, is one tool that, out of the army of tools that they have created, that helps them accomplish one thing, which is high level of predictably accomplishing video delivery to the end user. Now, what does Chaos Monkey do in practice? Imagine if you have a full set of machines out there in the cloud doing some business, like whatever the purpose may be you assign to those boxes. And so what this Chaos Monkey will come and do is literally randomly unplug these computers one at a time, sometimes multiple machines at a time, and just, basically destroy it. Randomly goes on shutting off machines out there. That's one of the activities, and this is done by this Chaos Monkey software. It runs on the Netflix cloud, literally destroying machines. And this is by design. They have implemented this software, and they let this monkey loose in their data center in the cloud, primarily to accomplish this creation of chaos by design, so that they can write their application software, their infrastructure software, so that it is able to survive the onslaught of this monkey. And even though that this Murphy will strike, what if Murphy doesn't strike enough? Maybe he will, but what if Murphy doesn't strike enough? So they let Chaos Monkey loose on their own machines just to simulate creation of problems and design their software in such a fashion that it is able to still continue to perform the function of delivery of videos to the end user, from the source all the way to the destination end-to-end pipe, making sure that that flow continues to operate, even though certain parts of their infrastructure will go down. And if it doesn't go down by itself, they will make sure that it does by unleashing the Chaos Monkey. And that's just a nice way to name it, nice way to brand it. But essentially, this is a systematic test methodology where you're deliberately causing problems by destroying machines and making sure that your end user is still happy about it. And that is how they have written their infrastructure, written their applications, as just one example. There are many such examples we'll discuss, and I'll illustrate some of those to you as we go along. But this was just a reference to one Chaos Monkey toolkit that helps them actually create problems so that they can write their applications in such a fashion that the problems, even if they are manually created by the monkey or naturally occurring problems that might occur during, because of Murphy, any of these situations they can actually address and continue to keep the customer happy. Now, in order for the customer to remain happy, there are some things that we need to be able to do. So let us try to understand what are those things from a high-level perspective. From the high-level perspective, what is it that Netflix needs to do? A top-level laundry list of things that Netflix needs to make sure that the infrastructure that they lay out in the cloud actually accomplishes this ultimate goal of you getting the movies all the way through and through Netflix, all the way to your devices. So this is the source, and this is the device that I'm talking about. That is the one in your hand, one in your home, wherever you are. And you are basically going through the Netflix infrastructure to receive whatever they want to provide it to you, and you pay them money. And they will give you movie watching experience. To enable this scenario, what are the top level things that you need to basically do at the very high level? Not going deeper yet, but at the very high level, get new movies from the studios and understand the date on which they will release to the Netflix network so that you get announcements about new movie showing up, make that movie visible in the catalog of movies, and have you select and allow you to watch whatever you feel like. That's the top level scenario, right? Primarily. But in order to enable this scenario, we need to go deeper, and we as we keep going deeper to peel the onion layers as we go along. Let's take one thing at a time in order for us to understand how will you actually get movies from somebody, from some company that provides you a license to distribute the movies out to your customers. So essentially, you will get a very large file that will represent something like an IMAX resolution, and this is just a proxy. As a proxy, I'm using it as a reference proxy. Essentially, the file can be whatever the provider provides, but it's typically a large file. that has a very high resolution, extremely high resolution. And this is considered the original file or the source file, if you will. Now, we know that this source high resolution file cannot actually play directly on the iPhone. We know that. iPhone is small, 960 by 640, whereas this is heavy. And so you have to do something called, shrinking that big file into a small size, and also encoding to the appropriate codec needed. So we need to go compress the big file into a small file and then encode. So there's a compression involved to make it small, and encoding. So these are heavy duty work, literally very heavy on the CPU. So you need high performing compute power to make sure that this encoding and compression happens. There is a library in the open source called FFmpeg, which does most of this work, by the way. And this library, as you know, is a cross-platform, complete cross-platform solution to record, convert, and stream audio video. That is what this library does. It is available on GitHub or somewhere. Yeah, it is on the GitHub somewhere. You will find it. They have their own Git repository somewhere on ffmpeg.org. So they don't have it on GitHub, but yeah, it is open source. So you can download that software in source code format and install it. Linux machines have it built in. Macintosh you can install through Brew. Windows, there is a binary available probably. So for every operating system, like Linux and Windows and Mac, there is a solution available where you can use this library to transcode. Primarily, we are talking about compression and encoding in the variety of target formats. So as you begin, this device is just one of those many devices that you have. And out of those many device types, we need to understand that the target compression and target result. So you have to have a resulting file that corresponds to this device, and another file that corresponds to the Xbox, and another file that corresponds to, basically you are creating a from a source file. Let's say source file for, let's pick a movie name like the Incredibles. So this is the movie Incredibles, for example. Incredibles dot, the raw file you get from the source. Excuse me. So the original source file you obtained was the large size raw file, and you have to convert this, transcode this, compress this into a variety of formats for the target devices, such as the iPhone target, the iPad target, the Mac target, or the Retina target, I should say, and the Windows target, the Xbox target, the PS2 target, PS3, 4 target, the Nintendo target, and it goes on and on. So for every target device, you need to have a specific file that is transcoded and shrunk to the appropriate file that will play on the screen to adjust, and also appropriately encoded using this encoding software, like I said, FFmpeg, which is an exhaustive library, by the way, available, and it is cross-platform, meaning any operating system can run it. And this is just one such tool that is actually pretty darn useful for companies like Netflix that are doing transcoding. There is another one that is a derivative of this, and that is called Mencoder. And this is a command line transcoding tool available on this website, which is also pretty darn useful. So you have sites like encoding.com will perform the service that I'm talking about right now, which is what this site will do is that once you log in or sign up, what they will let you do is encode your projects in the cloud. What that means is if you have something like a large video file, let me show you what I'm talking about. So the Saturday before, when we ran that special session, if you recall, we were able to create a very high quality video through a special software that I'm actually running in that machine there. What we were able to do is construct a very high quality 1080p HD video that shows here. And if you go to YouTube, you will find that video is actually very high definition, available up to 1080p. Now what this does, as you can see in the resolutions here, we have 1080p HD also available. Now I was able to get this high resolution because the resulting file that actually happened on that Saturday night when we ran this 2.5 hour session, the actual file turned out to be about, in its fullest, highest resolution. The original file that I'm talking about was about 126 gigabytes. Now it is impossible to send this file to YouTube because YouTube has a file size limit. Let's see what the YouTube file size limit is. It is 128 GB. So I think the actual size was 143, not 126, but 143. And so it is impossible for me to send a 143 GB to YouTube because YouTube would not accept it. In fact, many of the places where you have Comcast, connection will get dropped and the file will not actually go up. And by the way, sending a file in the raw form to YouTube is probably not a good idea because YouTube doesn't like that. And so the best way to actually send whatever you want to send to YouTube or to the appropriate target, like in our case, whatever the target may be, is to understand what they need. So we are trying to understand what these guys need. What does Retina need? It needs 5K resolution. So what does Windows need? Whatever the machine has. So we have all variety up to 4K is supported on Windows. What does Xbox need? Xbox now supports 4K also, and sometimes the older Xboxes have a 1080p max. And so that's the resolution. PS4 supports 4K, I think. I don't know, but yeah, so depending on the target, we need to understand what can they actually expect from us when we are playing something on the device. A file size of this heavy, big file, it won't even play unless you have a high performing machine. You cannot really play this on a magnetic hard disk. It doesn't play smooth. And this is just about 2 hours and 13 minutes of video. And so what I needed to do is actually convert it down to an appropriate size that YouTube will accept. And so what you see here, actually not here. Let me close out. What you see here in this screen is a 1080p maximum. You can send higher quality videos also. However, what I actually did was to convert that large video that I was talking about, this heavy file, down to a size that is about 15 GB. That was also heavy, but then I also make sure that it is encoded in the formats that are streamable, and so that YouTube can properly send it and play it correctly. And now this is not necessary in all cases. You can actually send a non-streamable format to YouTube, and YouTube will then take its time to convert that into a streamable format, which is known as video processing. Video processing, YouTube. So you may have seen that when you upload a video to YouTube, it will say that, your video stuck in processing. This you may have seen occasionally. You will see this problem because video is being converted from one format to another on the backside in YouTube. What they're doing essentially is making it streamable. And then they will say that the processing has finished. So this conversion of movie formats in the process, encoding it and compressing it to a target device, is actually done not only by Netflix, but also by YouTube. YouTube also does the same thing depending on the target device, whether it is iPhone, iPad, Retina, whatever that device may be, whatever choices that people will watch YouTube on, they will have a flavor of a file originally based on the source, but then converted into a target format. And when an iPad or an iPhone or any other device hits that site, say this site, for example. If you hit that site, and here you will find tons of videos, but I think only I can see all of them. I occasionally will expose only certain videos outside. So here, what you will see if I go to the video manager location, which is where the video is, I think it was this video. Maybe not. Maybe yeah, it is one of these videos. I forgot. Yeah, it is this video. So the idea is behind the screen, YouTube will keep a copy of the same video encoded in a variety of different formats, because it does not really know at which time which device might actually hit that particular file. So this page might get hit from an iPhone or another device or Android device. The screen size will be big or small, and the underlying operating system may be different. So it has to address that codec, it has to address that size, which requires even YouTube to do a concept which I'm calling compression and encode. Those two factors together I generally call it transcode, and the target will be all these devices that you want to be able to support. And the source will be the original video file that you will get from the studios, the movie studios, and you will target the iPhone, the iPad, the Mac, like that. And you go, the list is long. This can be long. And so you basically are creating a ton of different files and storing them somewhere in a streamable format, and having that streamable format render to the user. That's one activity. Now, the other activity that needs to happen is that you need to prepare a catalog, something that looks like a screen where I have a choice. So select your movie, please. And so here's a list of movies. And so you just click the play button for that particular movie you want, and it will start playing. That choice given to the user needs to be presented to them in form of some kind of a web application, so that the user can then go to the www. Whatever that address is, in this case, netflix.com, and log in. And once they log in here, then the choice or choices and selections and lists and preferences and settings, all these settings in terms of the web application that the company will need to provide as a front end for that particular user to be able to consume the selection, the choices available, and then appropriately click any one of these buttons to start playing that movie, and which will then start on the target device on which they are watching just that particular experience. Now, this is just the encoding and rendering portion, but let us try to understand how will this actually work out in the context of the Amazon cloud. So what I'm going to do right now is to go to the AWS site, where they actually have a very nice example picture for this. So I'm going to look for it and give you a link. So I'm looking for the content and media serving page. Yeah, this is one of them, but not the best one that I wanted to. There is another one. So let me go to that main page and identify the one that I want to give you a link to. And that will help us understand which one is the one that I would like to talk about, because it is actually a pretty nice and a decent example of generically applies to both YouTube as well as Netflix. So here, I'm going to grab that link and then send it over to Slack chat so you have a local copy. So there's a link coming in Slack. That's a PDF file, and we are going to use that reference here to talk about the things that we are actually going to talk about. How will a scenario that I just described actually play out in real life in the Amazon context? And the same concept can be applied to other examples also. And so there's a Microsoft blueprint, Microsoft Azure blueprint also available for this same thing. And I'll describe that also to you in just a few as soon as we get there. And so those blueprints are available here. And I'll talk more about these, but let us talk about one cloud to begin with, which is this, which is where Netflix actually runs. So let us look at this picture carefully and try to understand. And you have a local copy of this. So what I'm going to do is actually switch over to the full screen mode so you can see it carefully. And in here, let us traverse through this drawing and this illustration carefully so that we really understand what's going on. So there are some numbers here. I'm going to zoom out on or zoom in on particular portions of this page to help you identify where the things begin. And so in this section, if you look at, let's say, the very bottom left corner, and let me download this thing locally. So it's better for me to just run it local as opposed to and so what I'm doing is downloading that PDF file and then playing it locally. Oh, I should have just saved it from here. I'm such a nerd in Terminal. I cannot even want to download this. I should just right click and save it. Isn't that? File, save as, that should export as PDF. That should just export it right there. As opposed to going the way I was doing, which is, this shows me how nerdy I can be at times. Well, all the time. So here we are, save it in documents, and then we'll switch over to the documents section. In the documents, and there is that file which opens up, and it will zoom better, I think. So here, I hope it does. No, it doesn't want to zoom now. What? Oh yeah, it does. So we will use that instead. Yeah. So at the bottom, you see there's reference to DNS. You see this here, which is basically a Route 53 implementation in Amazon, which is a DNS server, as you know. And so that's the beginning point for us to start thinking about. So let us do a comparison of what we are talking about with this sheet of paper on one hand and this drawing illustration on the other. So I'm going to put them side by side, and let us see if I can manage this side by side, please. There we go. No, not yet. Yes, now it's okay. So what I'm suggesting is this Route 53 that we have here is essentially a DNS server. And so if anybody as a user will want to go and visit Route 53 or say www.netflix.com, the first thing that happens is actually a DNS query. And so it translates to that front-end endpoint where it gets an IP address. It gets an IP address of what? It gets the IP address of the exact location where the actual servers are running. And that is what this user will eventually, this is not really ideal, hold on. This is not good. So let's go back to the browser. And in the browser, you see this user, this guy, he is going to get that DNS entry from there and will then, this is the end user of Netflix, by the way, and he or she will do is get that IP address converted from this Route 53 and then visit this location, the Elastic Load Balancer location, this blue highlight that you're looking at, which is this machine or this set of machines that is actually balancing the load among these web servers. These web servers that you see here, they are practically scalable in terms of EC2 resources here. And you see this number 7 and this yellow object, the auto scaling group layout at the bottom, essentially is a reference to the fact that these web servers are rendering what I showed earlier in terms of the user experience, which is when the user visits that site, they get choices and movie names and pictures and thumbnails, pictures of that, and they can basically select a movie they want to play. And that experience, this whole experience of the user interface becomes available to them through this web property, which is a collection of web servers. And these users, when they come, they will hit this load balancer, and they will get assigned to one of those web servers. And that is how this auto scaling group will address and basically show, this web server will show the number and the selection and the choices of movies available by loading it from the data store at the back end. This number 6 item, number 6 is essentially the data store. It is, think of it as a database, if you will. And that database or data store will give this web application the ability to render that experience through this load balancing element to this end user. So this end user can then choose whatever device they want. Could be an iPhone, could be an iPad, an Android, or any other, basically any other equipment that they want to be able to play with at that moment, and get that experience rendered on their machines so that they can select and browse the data available there in terms of which movies. And this is the information about the movie, the data about the movie, the metadata, the album art, the cover, the name, the artist, the picture, the actors, and things like that. And that data is coming from the data store. And that is how it's getting rendered on the upper left portions: data store, web servers, and auto scaling through a load balancer, where this user is getting that experience, the first experience that you will see when you go to netflix.com, for example. So you go to netflix.com here and you log in, and what you're really looking at is that experience that I'm just describing to you right now, which is here. And that is this user watching the list of movies available, and you can sign in and you get an experience of the selection of the choices available to you. And that is what you will see when you visit this load balancer. Basically, netflix.com, the front end. How does this data store get populated? That is the next logical question. Where does this data come from? Like, who's putting data in there about the movies, about the selection, about the subscription of that user, how many movies can they watch, and how much they have paid, and things like all those things, the commercial aspects of it, whether the money in the credit card is on file or not, is it being charged properly, have they paid their bills or not, all that data is also stored in that same machine. And you will basically see that experience of billing, account receivable, whatever that thing is regarding your customer relationship with the company, through these web services, expandable through this yellow colored object, which is the auto scaling group. So these machines or web servers will scale out and scale back in as and when the growth is, number of users goes up. The machines that serve these users, like web servers, will also grow up according to the demand that you have placed on by the users themselves as they hit the load balancer. And that's the scenario of scaling in this context. Now, on the other end, the data store, who's going to fill the data in that data store is the now logical question, the next logical question. So imagine now this other person who's probably a Netflix employee. Think of it as a Netflix employee. And that employee, again, represented by the same picture, this guy, now a Netflix employee, not you and me, somebody internal to the company, also visits the internal site of Netflix, which is how he or she will operate on. And they will basically be inside the company and will look at a different view that we don't have a clue of how it looks like, because at least I never worked for Netflix. So that person will effectively see some portal inside, which is going to allow him or her to manage the content that the users or the customers will see. And that is what I'm trying to now describe to you. So imagine a case where this person, who is a Netflix employee, now receives those sources, like these sources I'm talking about, that needs to be compressed and encoded and transcoded in all these target devices and all that. That work needs to happen. Somebody has to do that work. Whether it is some person or some machine, that's a different case. But it's mostly machines. Nobody is doing it by hand transcoding. That doesn't work. So the idea is this person is collecting these video files. Imagine that these are the original source files coming from Hollywood studios or Bollywood or whatever other word. Or basically some content creator is giving them these sources. Now these sources basically are very large movie files that will just not play on any of yours or my computers because they're not designed for it. They're designed for playing in highest possible quality on places like IMAX Theater, for example. So you will receive them, but Netflix employee receives it, but they cannot do nothing with it. Like literally, practically nothing unless they process it. So this processing pipeline is what I'm going to talk about next. And that processing is what happens on this lower half of this particular image, including all this element. So all of these guys, except what we just discussed. The data store also plays in this processing pipe. The web servers and the auto scaling group here and the load balancer, these parts are customer facing. So they will give the customer facing experience to the end user. However, everything else here primarily is dealing with the idea that I'm talking about, which is now that I have this original movies from the movie studios, I need to do some processing so that the end user can actually receive those movies and watch them, enjoy them whenever they feel like, whichever device they want to enjoy that experience on. And so imagine these movies are now coming in. The next idea is to have these movies somehow upload to the cloud, right? It is coming from Hollywood. You need to somehow give it to the cloud. So for which there is another load balancer. And this load balancer basically handles the amount of incoming traffic of videos coming from sources. Sources are primarily Hollywood, Bollywood, things like that. And this elastic load balancer, this one, will load balance the load of incoming workload, which is going to basically be sent over for transcoding, which is compression, encoding, and all that. And so that load balancer will allow the workload to be distributed among these upload web servers that facilitate uploading the content incoming into these clouds, into that particular cloud example. So these black colored EC2 boxes, as opposed to the white colored EC2 boxes, these are white colored boxes here, these are black colored, and the idea behind these boxes in the black color are primarily the fact that they will help internal Netflix users in uploading the content over to the cloud. Now, what does that do actually? It will take the original source file as is, and first thing, put that in a bucket in S3. So that the big square in the middle, big box in the middle, is basically representation of Amazon S3, which is simple storage service, as you know already. So the files coming in through a load balancer, through an upload server, being sent over to the central media repository. So think of it as another bucket in the cloud, S3, where the actual raw files, these files, sources, are getting uploaded. That's the one thing that you will immediately do as soon as you receive a file, just put it in S3, right? First thing. Next thing I would like to ask is to please mute, because there is some noise coming. I think some kids are playing in the background. So please mute. Next thing is that this S3 bucket now has all the original sources, at least for this batch of movies coming in. You have all these original sources already uploaded by these upload servers. Okay, great. Now what? What's the next action needed? And that action is basically transcoding, right? You need to convert those media files that you now have in the repository here in this S3 bucket. There can be multiple buckets. This is just one bucket being shown, but you can have multiple buckets. Or you can just put everything in one bucket, depending on how you want to classify. That's a different story. But the idea is that this central location has all the sources now, and what you need to do next is to assign a task, some kind of a to-do list. So you're basically putting a to-do list. Now that I have these movies, S1, S2, S3, like that, all the way through S17, for example. And these are the 17 movies I have received from my sources. And I have put them in a bucket for simple storage service in the bucket in Amazon Web Services. And so these movies are now available in the bucket, and I need to process these 17 movies. So what I will do is put a to-do list. And that to-do list is basically assigned to some computer. Some machine needs to do that to-do list, and they will do it. What is that action needed? For S1, S2, like that, S17, and so on. The action needed is transcode. And do this for every target device that we support, like iPhone, iPad, Mac, and goes on. We have a list of devices. I would like each of these movies, 17 of them for right now, to be transcoded into this target, this target, this target, like that, all these targets. So as a consequence, we will have, let's say if we have 7 targets, for example, not more, just 7. If we decide that, all these variety of devices, we will support only 7 target devices. We'll support, let's say iPhone, iPad, like that, only Mac, PC, and Xbox. And that's these 7 devices that I want to support. If that's the case, then we will end up with 7 times 17 sources that we now have. And we'll end up with so many, which is 7 times 17. So 119 movie files, plus 17 original. These are transcoded files. That's how many files we will receive as a consequence of the processing. And so for every original, there is going to be 7 target files, because we decide that we will support 7 of these target devices. In practice, you see that Netflix supports a whole lot more. So we will have let's say that whole lot more happens to be 27 devices, then it becomes a different number here. But the idea remains the same, that you need to transcode and create movie files. And that is what this to-do list is actually. So the to-do list becomes, to-do action list is to transcode S1 into 27 formats. Next action, transcode S2 into 27 formats, like that. And like that, this is the action list of S17 and so on. So that's the list of actions. This to-do list needs to go in a list. In other words, a queue. And this is what simple queuing service does. So Amazon has this simple queuing service available here, which basically is a queue. It's a queue of things that needs to be done. It's a to-do list. In simple terms, in practical terms, it is a to-do list. A to-do list for machines. Simple queue service. So what you're looking at is this queue of to-do list. I need to do this, 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 and go on. So as I'm doing these things, I will put those in a queue. So I'll put these things in the queue. So like this is like the to-do item number 1, to-do item number 2, like that. And I'll keep accumulating them. Say I have 17 items, and then I can add more as new movies pop up. The new movie comes along, it becomes number 18 to-do item. And that's how the queue will grow. SQS will grow. As we finish processing this item and convert into the target device files, the queue will shrink in the SQS, because that to-do item is now considered done item. So the queue shrinks. Another item done, the queue will shrink again. And you will find that this simple queue service, queue height, is fluctuating. Sometimes it is this full, sometimes it is all the way full. And by the way, it is limitless. So there is no limit to it. So it's practically limitless. You can keep adding items in the list. And you keep doing them. So once you're done with this, say done. Done with this, say done. And like that, So the queue will grow and shrink automatically based on how fast you are processing them and how fast new items arrive. So the processing versus new items arrive will depend, and that these things will actually determine the height of the queue in the simple queuing service. And that is what this SQS is. You're basically putting a job queue, a queue of things that are being uploaded here in the bucket, but they need to be processed. That's the queue. That's the to-do list. Now, in this other end, you have here, what you're looking at is another auto-scaling group. And this auto-scaling is this yellow thing that you're looking at here, the yellow item. And what this does, it also has Amazon EC2 machines that are basically processing pipeline. They are these black boxes, 1, 2, 3, 4, all these guys. They are basically helping you process, meaning they're helping you in encoding. Encoding what? That original source file, transcode S1 into these formats, transcode S2 into these formats. So you have those 4 boxes in this picture, black color, 1, 2, 3, and 4, that are constituting the processing pipeline. However, as you will see, it is actually a part of an auto-scaling group, which means the number 4 of these 4 black boxes, it does not limit itself to only 4 boxes. It can grow or shrink depending on how much work needs to be done in the queue. If the queue has more work to do, you will scale it out and add more black boxes that will help you in processing faster. And when the processing done faster, the queue will shrink. And when the queue shrinks, you can let go of these boxes. You don't need them that many boxes anymore, so you can just let go of them. And that is how this auto scaling works, because the queue will determine how many machines do you actually want. And so in this example, we have this to-do list. The to-do list can shrink depending on how fast the processing is happening, and can grow depending on how many new movies are coming in. And so if there are new movies coming in, then this queue will grow. And so the idea that we have is a slightly different idea than we have here in this web servers. And auto-scaling group is slightly different than this auto-scaling group. Can you tell me the difference between this auto-scaling group and this auto-scaling group? What is the difference in the driver that makes it scale out versus scale back in? What is the difference between the black colored auto-scaling group and white colored auto-scaling group here in terms of the characteristic of scaling out and scaling in? What is it that drives scaling out in the black? What is it that drives scaling out in the white auto-scaling? So that's a question.
Okay, Nilesh, this is Salam.
Hi.
Hi, how you doing, everybody?
Pretty good. Go ahead.
Okay, so the white web server, that will implement for the user, end user.
Right.
And the black one is going to be track or scale, what the movie is going to be coming in the flow. So there's going to be tracking by these two.
Right. In the white colored one, if there are more users coming in, that we need to address more machines because there are lots of users, right?
Correct, yes.
Lots of users, so let us add more machines. A very simple rule there, right? Very, very simple. If there are more users, more machines.
Correct.
Right? Whereas in the case of black, There are no users as such, but there are to-do list items, work items. So if there are more work items, you better add more machines, because otherwise your work will accumulate and the queue will grow. And it might grow to a very, very large height, but you want to keep the queue in a reasonable size, not necessarily very large, or not necessarily tiny either, right? You want to maintain the queue, so it's not that the queue is getting upset and that, hey, you are not giving me good experience, your black colored machine. I need to get good experience from you. I need to keep my queue length 0 because I am your customer. That's not the case, right? There is nobody to complain. It's a queue, man. Come on. The customer will complain on the white side. The customer will say, hey, your website doesn't work. Netflix sucks. That's the case. Whereas in this example on the other side, where the black colored queue is containing other auto scaling group, there is nobody who will actually complain to you that your machines are not processing fast enough. Is that correct?
Yeah.
Yeah. So what does that mean? Why am I saying that nobody will complain if the queue is accumulating or piling up? If work items are piling up heavy, nobody's going to complain. But on the white side, if the customers are waiting in line and getting to open the Netflix site and the site doesn't open, they will complain. And then they will go away to another company. We don't want that. That's understood. That part is understood. But what about this black item, and why am I even talking about it? That's the point. Why am I talking about this item queue being upset? You're not processing my queue, so I'm angry. I'm going to file a support case or something like that. That doesn't happen. It doesn't even make sense, right? So why am I even talking about it? That's the question. What do you think? What's the difference? Like, why am I even discussing this? So the answer, I think you may not readily guess it. May not readily guess it. And that is the subtlety. There is actually a fundamental difference in this black versus white. It's just a color, by the way, but there's a fundamental difference in how the need for processing is immediate on the white side, where the customer is waiting. You need to immediately provide them with a web server and have them get a good experience as soon as possible. Whereas on the black side, it is not critical. That is the fundamental difference. Now, why does it matter? Right? Let's understand that. And I would like Salam to stop your fan or mute yourself, one of these two. You have a fan going in the background, right? So that fan can stop, or you can mute yourself, either way. So the difference essentially is like this. When you have a criticality versus non-critical, right? The other one is not critical. It's a queue, SQSQ. It's a queue. It's not going to get angry against, why are you not processing? My queue is growing in height. So it is growing like this, process faster. It is not going to complain to you. It is not critical. The customer will complain, and it is actually critical. So
because customer facing, right? Customer facing and non-customer facing.
Yes. This part is non-critical. It does not matter if the queuing and the processing does not happen at all on a day, like zero processing, no processing. All these machines are shut down. The black machines here in the auto scaling group, if you shut them down, it does not matter. Do you know why? One day, just shut it down, the whole thing, all of the black ones. Processing stopped. Why does it not matter?
I mean, as long as the SLAs are met, like for the incoming queue, the media processing subsystem, like suppose Disney is giving a video DVD to Netflix to put it on their Netflix system. Suppose if Disney gives a 1 week SLA, as long as Netflix can meet 1 week SLA, then they are fine. But if they are not able to meet 1 week, then they are doomed as well here as well in the processing subsystem also. That it's not able to It's not
Yes.
able to process the queue
Yes.
and make it available to the users.
Yes, exactly. And the idea essentially is exactly that, is that it is really about the SLA, right? So if you have a new movie that is going to come out 3 months down the road, I'm going to announce it and make it available on Netflix. But I have the source files right now. I can wait a couple of weeks, doesn't matter. I know I can finish the processing in like 2 nights. No big deal. I can wait and maybe 3 weeks because I know I have 3 months. So I can basically go slow. I don't need to rush because it is not critical. Given that I know I have enough time, a lead time enough for me to actually make the movie available to my customers because the deadline is not on my head. It is still far, far out. So that criticality difference boils down to one thing, and that is money. So save money. How do you save money when it is not critical? Do you know? In the context of cloud, how do you save money for non-critical things? Do you know? It boils down to saving money. How does it work? Anybody?
So you put it on a cheaper hardware. You put it on a spot instances, right?
Yes.
Put it on.
The spot instances, cheaper. It doesn't have to be slower. It is just cheaper. What does that mean? I said it doesn't have to be slow, just cheap. So I will show you a real life example as to what I mean. Here it is.
But for a company like Netflix, company the size of Netflix, they should not be. I mean, they won't be doing that, right? They would be probably have a dedicated compute optimized or C4 or that kind of a.
Yes. But still, everybody wants to save money, even if they are big. That's a fact of life. People will want to save money just for the sake of saving money because that's a good thing, right? And so companies of big size also will like to save money all the time. It is a universal characteristic. I have not seen any company that says, yeah, it's okay to waste money. It doesn't exist. That company will not survive long term. And so the reason it is important, even though it might look small to you from a pricing perspective, it is a matter of few cents, but just multiply that by the number of machines they're dealing with, and then a few cents saving here. Let's say you save 13 cents per machine per hour. This is the saving. Let's say, just saying right now, if this is the saving on an hourly basis, now multiply by 24 hours and also multiply by how many machines you want, then it becomes a sizable amount to save, right? 1,000 machines, it becomes a decent chunk of change to worry about. And that's how savings get calculated. When your company is big, you need thousands and thousands of machines. So even a per hour 13-cent saving is a decent amount of money to think about. So now let us see where these savings actually come from. So you have this EC2 here, right? You try to get a machine, let's say, launch an instance, and you say, I want to get this server, and I want to get it, let's say, M3 large, that machine. That's a reasonably sized machine. So that one, M3 large. So let's find out M3 large pricing. What is the price? And so here is the pricing on an M3 large. And M4 large. So it's 12 cents per hour, right? EC2 price. Okay, let's remember M4 large and price was 12 cents an hour. Okay, good. Now let us find out if I can get.
How about the spot instances?
Yes, I'll get a spot instance now. Launch instance, select, and let's get an M4. What was that machine I was looking at? Not M3, but I was looking at M4 large, right? Okay, so we'll go select M4 large, which is this machine, and I know the pricing is M4 large, 12 cents per hour. So M4 large, 12 cents per hour. And let us keep going forward with actual selection of spot prices. So here, if I see that I am in Oregon region and that I will like to actually select a spot request. And what just happened? You see the pricing now, it has gone down to 0.0242. In West 2A, in West 2B, the price is 0.219, and in 2C, the price is 0.24. So I can actually put an eBay-like bid here. I can say, okay, I'm going to give you 3 cents, and you give me like maybe 1,000 instances, and put them in my default VPC, and I will go next step and add some storage. And when I do this activity, what will happen is that I will get assigned 1,000 instances to do the work that I want to do in this black colored processing pipeline. I will get 1,000 machines at the price of
3 cents.
0.204. This number, 3 cents, is the maximum price that I want to pay. And it needs to be higher than these numbers. If it is not higher than these numbers, then I will not actually get any machine whatsoever, because I am actually bidding. This is like eBay bid. So if you know what eBay and bidding is, that's exactly what this is. And so maximum price you're willing to pay per instance hour, and your instances only if the spot price is greater. So if you have these, hey guys, please mute. Hey guys, please mute. So this number that you have, if these numbers are higher than what you are willing to pay, you will not get a machine. If these numbers that you will want to spend money on, if this number is say 4 cents, you're very likely to get a machine at the lowest possible price. So this is the price that you will actually see. And you can have that request valid, and you can say that I want to run only in the late evening hours, and valid up to, you can set dates on which I want to run it. So my $4 cent price maximum is valid only on these dates, and make that request persistent, and maybe remove those validity dates and keep the request persistent if you like. I'm going to pay only 4 cents. So if you are willing to give me up to 4 cents, whatever the demand price is, the current spot price, I will spend that money. So this number is very likely to what you will receive compared to 0.2. So you're effectively saving about 10 cents. Multiply this by 1,000 machines, and you are saving $100 an hour. Just on processing, right? Just on processing on 1,000 M4 large machines, you end up saving $100 an hour, which is not chump change. It's an hourly rate for a decent sized employee, and so that is a good amount of money saved over the year if you're running this on a yearly basis, which, by the way, large companies like Netflix do. And so your cost saving can be very, very effective if you are actually making use of concepts such as spot instances. And here, if you don't take spot instances, your pricing will be 12 cents. If you decide that I want to take a spot instance and I'm willing to pay up to 3 cents maybe, the maximum risk is going to be 3, and the money guaranteed to save is going to be $90. That's an effectively guaranteed saving, and 90 or more, very likely a little bit more, $90 to $100 of saving every hour is what you will end up saving. If you decide to go this route, which you can actually choose spot instances, because this need of killing this queue height, reducing the height of the queue, is not as business critical as making sure that the customers are happy and being served the content that they're looking to get. That need is different from this queue processing, is a different need, and that is why in this particular picture you have a reference to spot instances, clearly called out that these instances are actually good if you make spot instances as opposed to full price instances that you will end up paying when you don't request spot instance. And that is a scenario where companies actually save money because it makes sense. Because you know that your machine configuration does not need to be immediately available. You can get whenever you feel like, whenever the prices kind of sort of match. You can find out this particular maximum price that you're willing to pay, and then it will automatically become available to you. By the way, spot requests and the pricing around that, the idea is that you can actually find out the spot bid advisor, and in there I think there is a place. Let's see where you can find the spot prices in a kind of graphical form. There is a place somewhere on the Amazon site where you can find out spot prices, current spot prices, history, AWS. So let's see if it brings up. Yeah, spot instance, history, go to this location, go to spot request, get started, choose cancel. Okay, so that's how you go to this location, spot request, get started, cancel, and price history. That's how you get there. So we will go to that same thing. We will go to Amazon and then go to EC2 and then spot requests, get started, and then they want us to cancel, right? Cancel, and then price history. There we go. So here in this chart, you will find an M4 large machine, the pricing over time in the availability zone of my choice over the period of last 3 months has been like this. That's what you're looking at. It's going to populate that graph and show you what the price has been over the last 3 months. And it is generating that chart for us. It's a little bit slow. But here what you see essentially is that the prices go up and down, which is expected, as opposed to staying at the same point, which is not considered a dynamic pricing in terms of spot market. So what I'm going to, this is like way too much for waiting, so I'm going to skip it and maybe try a different method.
Nilesh, I have a question.
Yes.
So what is the basic differences or disadvantages of spot instances compared to EC2 regular instances?
Yes, I will tell you that. Let me just get to a point where I can show you at least a week's history. Mm-hmm. And then I'll describe what I'm talking about, because here is one example. So let's go look at 1 2C. So here the spot pricing has been, recently it has been about, say, 2 cents. And so we go back in history, it was a little bit higher here. Like on this day, it was like 2 point something, a higher peak there. We have about slightly more than 2. And then prior to that, in the early in the week, like July 10th, the price was 1.67 cents, 1.67 cents here all along, right? In this time frame, from July 9 all the way through July 11 or maybe up to 12, the prices were about 1.5 cents or more, 1.6, 1.7. That has been the range of prices in this time frame, whereas the prices slightly go up a little bit and go higher right now. It is just above 2 cents. Now, the scenario is that eventually what Amazon will do over time, maybe a couple of weeks, let's say 1 month, you will find that Amazon will suddenly bump up the price at some point. And now is actually that time that you see in the period of 1 month. They bump the prices somewhere here in 21st of June timeframe. They bump the prices up all the way to 2 cents. And this time also right now in, say, July 13, 14, 15th, they are bumping the prices up again. And they do that primarily to do a cleanup on the cheapos, basically. What they do is they're killing out the cheapo people's machines. Those people who want to save money, like here, they're saving money and getting a M4 large machine at the price of 1.5 cents, maybe 1.6 cents, all along, all the way from June 24 through, say, June 12. So that July 12, that period of time, M4 large instances were cheap, about 1.6 cents. and they must have put in a metric of, say, my threshold is I'm willing to pay 2 cents, not more. And so if that is the metric that people will go when they see the pricing as something as low as 165, 167, they will want to put a limit of, say, 2 cents. Why pay more? And if that's the case, at the time when Amazon wants to make room and get rid of these cheap boxes, they will bump the price up. And they just did that at this moment, something like June 12th, 13th, that's what 14th is when they bumped the price a little bit higher up to this point. So like, say, 2.1, 2.3 cents maybe, or like that, 2.11 cents. And that is when you will find that all those machines that were occupied at a spot price of 1.6, 1.7 will basically cleaned out. What does that mean? What does that mean in practice? In practice, it means that if you get a cheap machine for 167, and you say that my maximum bid is, and then Amazon will say, okay, now the spot price is, what will this do? This is the Amazon's new price. This is your maximum bid. And you got the machine, you were using it all along, and you're still using, but then Amazon decides, no, the price is now this. What does that do to your machine? So you have a machine going, doing transcoding and this processing of the queue. It's processing your queue. And it is busy working all along, and then suddenly your maximum number is lower than the current spot. What do you think will happen to your transcoding? The machine will die. The machine will die and your queue processing will stop. And that is what Amazon will want to do to all those machines that are cheapos, want to kill them. Why would they do that? So now tell me, I'll give you an analogous example. The analogy is you have a Boeing plane. It belongs to Alaska Airlines. It is sitting in Seattle. And there are so many seats in the plane, right? You know, these seats. And all of these seats are full except these are empty. All these are full. Except these 3 seats are empty, right? 1, 2, and 3. These seats are empty. And the time of leaving this plane goes away at 11 a.m. from Seattle. It's going to fly out. And these 3 seats are vacant. And you are literally loitering around in the terminal at that moment at, say, 10:30, and there is nobody else. Everybody has boarded the plane. It's about to fly in the next 30 minutes. What do you think airline should do? And you want to go, but you don't want to pay the full price, which happens to be $499 for the flight to Hawaii. And that, by the way, Hawaii is a bad example. You will never find vacant seats. So let's go, you want to go to Tucson, Arizona. Yeah, that's the flight. Flight to Tucson, from Seattle to Tucson. The 3 seats are vacant and the price is $499, but you don't want to pay. You want to go here, but you don't want to pay that much amount, and you still have 30 minutes. The flight leaves at 11, and you're right there at the terminal talking to the Alaska lady and negotiating. What do you think the lady should do or can do? Forget about the fact that, imagine the Alaska Airlines CEO is there, and that CEO is discussing with you. What do you think the CEO can do? You don't want to pay this price. You still want to go in the same plane. What should be the price charged to you? So
they
that
could drop the price.
Sorry?
They could drop the price, assuming that you and 2 other people will take those empty seats.
Correct. The challenge is it needs to be profitable. They cannot take a loss, right? It needs to be profitable. So they can drop the price, but how much can they drop the price?
Until the variable cost of what it costs to run one person.
Exactly. The variable cost essentially is a bag of peanuts. Practically speaking, if the whole bag, you're supposed to eat the whole bag, that bag I'm talking about. So the whole bag, you need to finish the bag in the entire flight. That entire bag of peanuts is the cost, practically speaking, of this extra passenger. Because that's what they are going to give you. And maybe a glass of water, maybe Coke or something. But that's the cost is, say, $30, approximately, give or take. Now, tell me, how much should the price be for them to remain profitable, even on this new passenger that might want to go to Tucson and still not willing to pay the full price? How much they should charge? Imagine that this is the cost of the variable cost, which is $30 per person. That's the bag of peanuts plus Coke and some bathroom cleaning supplies and things like that. So that's the entire cost, $30. How much do you think the CEO of Alaska Airlines will charge you?
Well, it has to be above 30.
Yes, it has to be 30.01 so that they can make this 1 cent profit. It has to be profitable, right? And so they need to charge a little bit more. I'm just saying 30.01 figuratively, but a little bit more, $50, $100, something like that. They will probably give you as a token of appreciation and say, we'll give you a $300, $400 coupon and let you board the plane for only $99 because you're a good long-time customer and all that good stuff, and still make about, 99 minus 30 and a decent chunk of change. The reason is that they can do that because the fact that if they don't do it, they lose that 99 minus $30 right away. They are losing this money, leaving it on the table. If they don't pick it up, I think they are idiots, honestly. The reason is that at 10:30, they can grab this money. At 11 o'clock, when the plane flies, the value of that seat, those seats 1, 2, and 3 that are left blank and vacant, the value of that seat goes down to 0. It is worthless when the plane takes off. There is no value in the seat. The seat's value is actually $4.99, like 3 days in advance. Yes, people will gladly pay this money and occupy those seats, but if there are no passengers, nobody wants to go to Tucson, then the idea is that the value that you are not capturing in that window of time, you're basically making a loss of $69, approximately speaking, but you are figuratively actually making a loss if you don't fill the seats. If there's a passenger standing right in front of you, you should have him or her sit. And that is exactly what Amazon is doing. Amazon has large number of machines, and some machines are occupied. People pay full price, or people pay contract price, commitment price, and those are occupied. But then they have this extra capacity, which is like the seat number 1, 2, and 3 left empty. And so what should Amazon do? This is what they are doing in spot instances. They are letting you keep these instances for as little as this amount of money, whereas the full price is 12 cents. They're letting you use this, as you can see in this chart. All the way from June 24 through July 12, the prices were very low. And then they suddenly see that there is a need to serve the main customer, the people who are paying full price, the people who have long-term contracts with them to make the machines occupied. And then this demand comes along to address that need, to address the full paying customer. What do you think they should do to these cheapos that are sitting here squatting and paying 0.168, sometimes 0.17, sometimes 0.02? you want to kick them out by raising the price. And that's what Amazon just did here. On that day, 14th, yesterday basically, 14th, is it 14th? Yeah, 14th, they kicked those guys out. And so all those cheapos basically died. Died as in the machines died, not the persons. The machines died. Those cheapos were ejected out of the Amazon cloud to make room for the people who are going to pay full price. That's what spot instances do. And the analogous example was this Boeing plane, 3 seats vacant, about to leave. You want to give the guy who wants to go but doesn't want to pay full price, come on board, welcome. That's what this spot instance practically is. Now, the challenge with spot instances is that it will magically disappear on you because you bid only so much that you want to, and if the prices of that instance go above that maximum that you have set, these black machines will disappear. They'll just die, and your processing will stop. And that is totally fine because you don't really care at that moment. All you can do is maybe spend 3 cents and put a revised budget, and you will get the machines back, and the processing will continue. Maybe it will take some downtime, and who cares? I don't really care about downtime of processing of that queue because these customers is what I really care about. And so I'm going to spend any amount of money needed to make them happy. I don't really care about this job queue. I mean, I do, but not as emergency as this situation. I want to address this whenever I think I can, practically speaking. And yes, I will pay money, but not top dollar, not 12 cents. I'll pay 2 cents, maybe 3, but not more. And I keep spending that money on these instances according to what I see in the history. I'll make my own judgments, and I'll put policies around how much can I bid, how much do I want to spend over time based on my past experience, and I will adjust my infrastructure and this processing that goes on. So when these machines are now available, now that you have clearly understood the idea of a spot instance, and when will you put that to use, the idea would be that these black machines that you see on the upper right corner, these guys, the processing pipeline will actually help to shrink this queue. This queue will go down. And Salam, if you can shut your fan down, that will be awesome. So this queue, if it goes down, then the number of machines needed in the processing pipeline also goes down. So you can actually kill one of those boxes, or maybe more of those boxes yourself. If the queue is really zero and there are no new movies coming in, and nothing new in the media repository, you can actually see that the job queue is zero, and your spot instances in the processing pipeline can become also zero because you don't need anything there. There's nothing to process. Why do you even need a machine to do some processing? There is no need. So just shut it down. That's how it works in practice. Now, when the processing actually is going on and finishes for a particular movie, say for example, one of those S's, right? We have the sources, source number 3. We converted that into all these target formats for all the target devices and transported those files, and they are now ready. What will we do is just like this source, the file number S3 is sitting in the simple storage service with Amazon Web Services. We will have these outputs also go in the same or maybe different bucket depending on how you want to organize. But these target files, which are now streamable to the target devices, are also sitting in some bucket somewhere in the Amazon cloud like this media repository. And not only that, you will make a reference of this repository in your data store. You will put that in the data store itself. That you will let the data store update to know that there is a new movie available. The movie is called S4 or S5, whatever that new movie turns out to be. Any new movie that pops in, you just want to update that data in the data store. And also grab information about the movie from the movie provider. So such as here is an example of this movie called Incredibles. And this movie, for example here, will have its director and the picture and things like that, all that data about the movie, this movie itself, and the cover, the detail, all that detail about the movie, who made it, and who are the people who are giving the sound bites behind it, and all that, the characters, the Elastigirl, and whatever those guys are. This information about the movie needs to also be placed in the same data store. The data store needs to know what needs to be shown to the user when they log in. When these users log in onto the web servers, they need to be able to show that, hey, we have a new movie. That movie's name is Incredibles. And by the way, it is available on such and such date. And that date also gets decided by the person who makes the movie. They will decide at which date can you actually release it to the customers, so that then this movie processing can happen ahead of time, can get processed completely and get stored in the repository, but not show. The data store will have information about it and will also have a future date on which the movie becomes playable. But until that time, the movie doesn't actually play. Once that date arrives, then this movie can become playable. It becomes a choice in the web server, so that the end user, Netflix user, can actually see that particular movie, select it, understand who the players are, who the characters are, and ratings and things of that nature, and then play it if they like. Right? That's the entire pipeline of what we are dealing with in this scenario. Now, a couple of things remain to be discussed, which are at least in this picture. There are a lot more things to be discussed, by the way. But in this picture, you will see this reference to a content delivery network and what this CloudFront is doing. What are these guys? Why are they sitting here? And why are they connected directly to this guy? And so that's the question. If you already know, help me understand. If not, I will help you understand. So if you know what's going on here, please tell me. And so the lines showing are content delivery network, CloudFront CDN, connected directly to the S3 bucket here in this black line showing here. And it is basically taking the content from the S3 bucket here and delivering it through the CloudFront CDN network directly to the end user. That's how it shows. But what does that mean, and why are they doing it this way, is the question that if you understand, please explain. If not, I will show it to you with an example.
Isn't that how they actually send you the movies? How they stream the movie?
Yeah. This is exactly how they stream the movies, through a CDN. So the CDN is basically alleviating the burden of serving videos away from the web servers, taking a load away from them, the burden away from these web servers, and burden is now shifted to the CDN, to CloudFront CDN to be specific. And the idea is that instead of loading up the web servers and asking these machines to serve the video file themselves, when it is playing, that video play happens from this content delivery network, CloudFront, which picks up the media file directly from the bucket and renders it to a player that he or she has in their hand, provided this person is authenticated already as a paying customer who has access to that particular movie stored in the data store up on top. That data store, if they have the appropriate rights and permissions and payment and subscription and everything else, then they will know that information from the data store, and as soon as it validates that, then the actual movie transmission and the streaming part is taken care of, is offloaded away from the web server over to the content delivery network. And this offloading happens through CloudFront that you have seen. By the way, we have done some CloudFront exercises before or early on, and I will now demonstrate a simple example as to how you can offload a particular asset. When I say asset, it can mean anything. There is a question in chat. Yeah, so the question in chat was a break time. So it's a good idea to take a break. So let us take that break, in fact, and then I will illustrate with a live example of what we are talking about. The time right now is 6:34. So we'll take a break up to 6:40. And then I'll show you a real live example that will help you clearly understand what am I talking about in terms of offloading the work from the web server over to a CDN. So we'll do that example live after the break. Let me grab water. Hey, I think I overshot by a minute. Sorry about that. So hope you can still hear me and you can see me on all that. So let us now see some examples of what I was talking about briefly is to offload the burden. That's what CDNs do. What do CDNs do? They offload the work, or rather I would call it grunt work. Work of what? Of serving assets. And what is an asset? They offload the grunt work of serving assets. An asset can be a picture, a movie, an MP3, things like that. Audio file, video file, pictures, a JPEG, for example, PNG files, like that. So these are assets typically used. You can have other types of assets also, such as you can actually serve PDF files, for example. And I just want to confirm that you can actually hear me. So just say something that you can hear me. I don't get that confirmation.
Oh, loud and clear.
Good, good. Yeah. Oh, yeah. Sometimes I mute and I forget that I muted. So that should not happen. So what I was talking about is these assets that you want to offload, and the grunt work does not need to be done by the web servers. Instead, give it to some CDN. They will let that CDN do the grunt. Now I will show you a real life example that will help you very clearly understand what I'm talking about. So here we go. And so I am looking at, let's say, my own picture. Is that a asset? Yes, to me at least. Let us get the image address. So copy image address. Let's copy that. And let us go understand that address in an editor. See this example. Where is it coming from? It is not coming from this site. It is coming from a CDN endpoint, as you see already. Right? Do you see that? Do you see what I'm showing you? Line number 3 and 1, the server is different.
Yes.
Right. Okay, let's see more examples. The chat request, CDN is a full price or spot price server. CDN is not a server, it is a service. And it is pretty darn cheap, actually. And it doesn't run all the time. I mean, there's no bill all the time. The bill happens only when somebody hits it. So that we'll look at the pricing separately just a few minutes from now. But let us understand a couple of things here. So I'm going to grab, let's say, I'm going to go to the back end of this site and show you that I will insert an image into this site. Just adding a new image, right? That's what I intend to do. So I will go to the media section in the media library, and here I will add a new media element. And when I do that, add new media, I'll select a file, and let us say if I can pick up a picture. So which picture do you want to pick? This one? No. Yeah, I want to take this picture. So I'll just take this picture and then choose. So what happens is, just watch it. I'm sending this picture from my computer to the site. The site is line number 3, right? That's the site. The picture goes up, and it is being sent. Right now, as you see in here, and that item showed up, and it showed up as I uploaded, right? So I click on the picture, and you see that the URL for the picture is different. But I uploaded it on line number 3, and it reached line number 6, which is this other location automatically, right? What was the magic? Let's figure it out. So this thing, abstraction.png file, which I uploaded, that now becomes visible as this picture, available as a media element in the library of things in the site. And you have all these pictures in here, but over the years they have accumulated. But the idea is that this picture doesn't actually sit on the CloudGenius server. So where did it go? And how did it reach in this location automatically? Like you saw that I just uploaded that picture file from this picture file number 5, and I gave it to line number 3. Sorry, I should rewrite that. It's a picture abstraction.png. I took that, gave it to CloudGenius site, and it showed up in a different location. What's going on? Let us understand. So I will show, first of all, I'll tell you what's going on, and then I'll show it to you how it actually happens. So I took that file, abstraction.png, and I gave it to this site. And in that site, I have a piece of software that takes any incoming asset and makes sure that it does not sit here at all. No, I don't want to burden my machines. If you remember, these machines that I have are actually Docker instances. And from my previous commentary that you want to not keep anything in a Docker container. The things that you want to keep them outside somewhere else, not in the Docker container. You don't store stuff typically in a container. You run code there, but you store stuff outside. And so that is exactly what is going on, is that piece of code that I have here will take this incoming asset and move it, not store it here, but instead move it to an S3 bucket in AWS. And then I have a CloudFront CDN, again on Amazon, that, by the way, this machine, as you know, you heard me enough saying it is running on vultr.com in a Docker container. You heard me say that. And so this machine is in a Vultr cloud. So it runs that code here, which will take that incoming asset and transport it over to S3 in Amazon cloud, and then hook it up through a CloudFront network which is also in the AWS, which is going to be my content delivery network, and then grab a link for it, and that link gets back to here. And that is what you see in this example. The URL for this picture, abstraction.png, is actually a CloudFront URL for cdn.cloudgenie.us. Let us understand what that URL actually maps to. So I'm going to go take that section here, go to a terminal, make it big, and then dig. What you see here, I'm going to do it again. So what you see, maybe a little bit smaller. And so what you see here is, when I dig that particular name, you're looking at, it is actually a canonical name pointing to this location, which is a CloudFront endpoint, which in turn is a reference to these multiple IP address locations worldwide, is what is showing. So if I take this entry and keep that in its place, like here for now, and open that location directly, what will you see? What do you think you will see? The picture itself, right? Like that. If I open it up, it shows the picture. That same picture, this line, which is the link I just opened. Now, having understood that part, what I will now do is take this CloudFront link and remove my CDN canonical name reference and override that, and then take this new link and examine its contents, go to a new browser, and you see the same thing. Understood. Next, let us also do another layer of abstraction, which is to go further down. So we were looking at this canonical name cdn.cloudgenius, which actually is a CloudFront reference to that long D3GL, whatever that name is, .cloudfront.net. So it's a CNAME reference, which in turn is actually a front end to a S3 bucket. Now, where is that bucket? Let's go see. So I'm going to go back to my Amazon Cloud, look at S3, and look at my bucket. And here I look at this file that I just uploaded, last modified date, sorting by last modified. And I should see that abstraction somewhere here in the list. Where is that? Abstraction, come on. Oh no, it's not here. It says level deeper. There are depths. There are a couple of depths there actually. So you see that the reference is in the WP content folder, uploads folder. That's where it sits. So you need to go to that folder, which is WP content, uploads, and then here are the files that you see in my site that are actually pushed out by the software to a bucket. And this particular one is called abstraction.png, which is this file. And that was July 15th at 18:26, which is like a few minutes ago. And not only that, this is the full size version of that file. It also created some sample, smaller implementation of the same picture to address a variety of representations on the website. So it has created a smaller size, 100 by 83, 1024 by 582, and all these other sizes, a square representation, 150 by 150. And you see that these other sizes are created automatically to adjust a variety of representation of the same full-blown picture, which is the original picture I uploaded. And it was uploaded and then converted into smaller sizes to address appropriate viewing needs. So conceptually, it is similar to what we were talking about earlier where you have a movie file, S1, S2, S3, like that, up to 17 or more. And for every movie, we are creating smaller size versions for target 1, target 2, target 3, like that, plus keeping the original movie itself, S4. So all these S4T1, S4T2, S4T3, S4T31, whatever those target devices you might have, these all representations are also stored in the bucket. That is what you saw here in this bucket. I now have abstraction.183, abstraction 1024.5.852, and all these image representations are basically derivatives as in converted from the original onto these other formats and placed alongside in a bucket. You can see that the timing is 1426, like 1846-26, 1846-27, 1846-28. A little bit of few seconds of delay in there in terms of its publishing here on the CDN. Sorry, this is not CDN, this is the bucket. So what we are looking is the Amazon S3 bucket, where we have a folder called WP content and uploads, and that's where these files actually sit. And they reach there because of the software that runs on this location and sends it over to a bucket, as we saw. Now, where does this CloudFront come into play? Let us understand that piece also, for which we'll go to CloudFront and understand that it is actually a front end that is running here. These are not machines, by the way. These are services. So they will get consumed by anytime there is a hit or a miss or a demand for the resource or demand for the asset. So in this example, I have this particular third item, which is a web distribution or web content distribution with this ID number, which has this domain name that you probably will recognize. So I should have clicked there. This D3GL, whatever that number is actually the one that matches D3GL right there. And so that is the same exact distribution domain name as you see here. D3GL is the item number 3, this one. So we should actually go and inspect that in detail. And what we are looking at is that this is a content distribution network endpoint. It has a web delivery method. It is deployed. It uses all edge locations for better performance. So it is basically worldwide replicated on demand. It is enabled. It has a canonical name reference of cdn.cloudgenie.us. It has an original domain name of D3GL, whatever that is. It has a certificate placed in its use, and it was last modified in 2015 when I basically edited something there apparently. And so the idea essentially is on this particular distribution, the origin for this distribution, the origin basically is a point where it gets the sources. So we are looking at this CDN that gets its assets from the S3 bucket, and that is called the origin for the content delivery network. And that is what we are looking at. In here is the origin, and the origin happens to be this bucket. This is a bucket name called CloudGenius, and it is an S3 origin. So it takes the sources from S3. The name of the bucket is CloudGenius, and that is what you saw me go when I went to that location in S3. I actually opened my bucket named CloudGenius, in which I went ahead and went deeper, by the way, in the WP contents folder, and then went into the uploads folder up on top. Come on, there, uploads folder, and then looked at the abstraction.jpg file, more available there. So it is going to show me the abstraction.jpg file, this one. I'm going to inspect its properties, and I'm going to grab this link from here, copy link, and take it in its place here probably. And so you look at this line number 5. is a little bit different from line number 7, is a little bit different from this new line I'm going to actually manually type, which you will recognize immediately. And so the original file came from, hold on. The original file came from my desktop, my laptop, abstraction.png. I uploaded it to line number 3, which is the CloudGenius site. And it runs in some cloud called Vulture, which is a different cloud, by the way, in Seattle. And the moment I uploaded the picture, it transcoded effectively, literally shrunk the picture to a different variety of sizes and created multiple images of different sizes based on the same original image that I uploaded, called abstraction.png, -100 by 50, or whatever the size number was, but created multiple files. Those files, this machine number 3 here, the CloudGenius server, the main servers, these servers in the Vulture cloud, sent that to the S3 bucket in Amazon. The bucket name was CloudGenius, and it went inside deeper into this folder and then that folder, and then put that item in there, and alongside it also place the other smaller items. So if you take this line number 5 and open it up in a browser like this, you will see the item rendered directly from the bucket. If you open this line number 7, you will see this item getting rendered a little bit faster because it is actually coming from a CDN. And then this line is a canonical name reference of line number 7. So 7 and 9 are CNAME aliases. So it is like Srinivasa Sama versus Srini, for example, or Muhammad Salam versus Mo, if you will, or just Salam. So it's a short name. The short name happens to be something that I like, and that is cdn.cloudgenie.us, which is basically a canonical name reference to line number 7, which is very difficult to remember. Cannot remember D3GL or whatever that is. So if I open this link, it also gets me the same item. If I open this link, it also gets me the same exact item, like here. So all these links, basically, line number 5, 7, and 9, are identical in its content. However, 7 and 9 are actually pointing to the same service. The service is called CloudFront, which is a content delivery network. And it is not a machine, it is a service. It gets its contents, the service receives its contents from its origin. The origin in this example happens to be an S3 bucket, which is line number 5, which is the CloudGenius bucket that I have defined. It automatically, anytime I put an item in the bucket, it automatically gets propagated on demand to the CloudFront network worldwide. And so by doing that, what I'm effectively doing is putting the burden of rendering these large images. All these images on the site are actually completely offloaded, by the way. This Docker container does not run or render any image whatsoever. All it deals with is the code and the HTML and the CSS and JavaScript. And even JavaScript is moved out, and CSS is also moved out, and some basic static HTML is also moved out. So the site runs efficiently because you are offloading its work to other things, other services. So in this example, to close out, we have a very small, actually, I spend, how much I spent? $40 on a box like this on Vulture, for example. It is able to serve a very large number of users comfortably at a decent performance, primarily because the work here is little. I have offloaded all this work of rendering assets out to a bucket. And that bucket has a CloudFront outside it. And this S3 bucket, which has the name of CloudGenius, by the way, in that bucket is where I store stuff. All the media assets, all JavaScript and CSS actually sits here. And to make work light and performance faster on this S3 is what I use CloudFront. Excuse me. And that is what line number 9 and 7, basically these are aliases. So line number 9 and 7 are equal. IP address wise, they're the same thing. They are basically representing the CloudFront. So 7 and 9 are together, same thing. 5 is the bucket. This is the line number 7 or 9. This is the number 5, which is the bucket itself. And this machine is the Vultr machine, which is running the Docker container, running line number 3. And that is why I can get away spending as little as $40 and still serve comfortably just one box. I don't even need, over the last so many years, I haven't actually had that need to scale, and I have customers worldwide that hit the site. And pretty decent amount of traffic comes along, but there is not much work to do here, not much. And so all the work is offloaded. And that is why I can get by with a cheaper machine. Now this question in chat was, is CDN a full price or spot price server? So CDN is not really a server, it is a service. And let us understand the CDN pricing to help you get that idea. CDN pricing. Let's be specific with AWS, CDN pricing or CloudFront pricing, and there we go. So here is CloudFront pricing. And so pay only as you use. That's the first fundamental concept of cloud computing, right? You pay as you go. Pay only if you use. If you don't use it, you don't get a bill. Like you will see that in my example, I have how many, like 4 or 5 different, maybe more CloudFront endpoints defined that I should actually retire, because I have how many of these? 1, 2, 3, 4, 5, 6, 7. 7 endpoints running, but not everybody's getting traffic, so I don't use them, so I don't get a bill. In fact, let's go look at my bill, and you will find a shock. My bill is going to be 0, but don't get scared. I mean, the reason it is 0 is that I have a credit applied, which is what I have from a different case, but let's understand the cost. The cost is really coming from a variety of usage scenarios, in which let us understand the cost related to CloudFront by service. A monthly cost by service, there is a cost to CloudFront in red color. And you see that last year to date, let us see, year to date, there was some cost in red color here, 37, how much that was? Let's see. EC2 instance cost, 56 cents. S3 cost, 37 cents. CloudFront cost, $0. Interesting. So the cost has been really, really low. It is not expensive, that's what I'm saying. It is not expensive. The pricing is such that it is new customers free up to 50 gigabytes. So all of you probably are new customers, most of you. And so you will get 50 GB of transfer out free. 2 million HTTP requests free each month, by the way, for 1 year. And then the pricing for various regions, if the end user of your content is in this country, like US, then first 10 terabytes of downloads by users in the United States, for first 10 terabytes of downloads every month, you will pay this much, which is how much it is? 8 cents. For the next 40 terabytes every month, you will pay a price of 8 cents. This is the per terabyte pricing, I think. So for every terabyte, you pay about 8.5 cents, then 8 cents, then 6 cents, then 4 cents, then 3 cents. And it's a reducing price structure. As you go more volume, they give you discounts, volume discounts. It is slightly more expensive in other countries. For example, India and South America, it's very expensive, 25 cents. India is also 17 cents. And like that. So the idea is this per GB price, not per TB, per GB. The per gigabyte price. And so pictures are really small. Videos is a different story. Pictures are small, as in hundreds of kilobytes, sometimes megabyte. but they're not gigabyte. And I don't serve videos from my site, so that's why my bill is small. If you are Netflix and you're serving videos from your site and you have millions of customers, this is a very, very expensive solution. I must caution you with that. It is actually going to be very expensive. So Netflix probably has a different solution of serving content, probably not using CloudFront. I don't know, but my guess is this gets very expensive if you have like a large video file that you want to transport to millions of users nationwide and repeat that in other countries. These pricing will kill you, like totally. So they probably have a different solution. I don't know what they have, but maybe they do. Maybe they use this. I have no idea. But we'll find out if that's a possibility. I will actually find out. What are they using for content delivery network? But the pricing here is expensive if you're doing really high volume, big files that you're transporting through their CDN. It is expensive. There are alternatives available to CDN. You don't have to use this CDN. You can always use another. And there are tons and tons of people that provide services. And that's the answer to your question regarding spot pricing or full pricing. Pricing of CDN, it's a service-based pricing, so you will not get charged at all if there is no consumption of your service. If nobody is hitting your site, there is no bill. Now, having understood these aspects regarding a particular item that you put, and you put that in a bucket and then transport that through a CDN, I think that was clear with the example that I provided, which is how this thing happens. So if I go back to my my site, original site, you will see that I can, in the media library, if I want to now create a new page, for example, and in there, I want to just use the image that I uploaded, it just behaves naturally, and I can add media, and it will go to S3, grab the list of items there. It is a little slow right now, but here, and then insert, and there I have it, and I can just preview my abstraction picture like that. So this picture I can just preview, it just automatically opens up. You will notice at the very top, the web preview shows up in my site, in the context of my site. If you right click on this image and say copy image address, it will show you the CDN reference automatically. And so it automatically goes to the CDN, grabs the appropriate links, and inserts it in the body of the post or new content you want to create, which is what we are typing here in this example. And so here is the image reference to a source that comes from that location with an alt tag of abstraction and a width of 30 and a height of 250 and a class of whatever and like that. And so that's the image file. It comes from line number 3, which is the source happens to be CDN. And that's what you saw me in real example. There's more chat request. Videos can be run in CDN. Yes, they can. And you will need to enable a streaming CDN. There are 2 types of CDN choices in Amazon. There are 2 types of CDN at least choices. The last time I checked, they keep adding stuff. But let's go check CDN again, CloudFront. And you want to create a new distribution here. So create a distribution. And there is a web distribution, which is the classic one that we have been using for HTML, CSS, PHP, graphic files, all the static assets. That's what you saw. And that's good for web distribution. That's what I just showed you an example of. And so you basically store your files in an origin, either in a bucket or your own web server, and you create a distribution by clicking this Get Started button. And it will walk you through, it will ask you, where is the origin, where are the files getting stored, and then give you a link for the CloudFront. That's what web distribution essentially is. The other distribution is an RTMP distribution. What RTMP is real-time media processing. It's a streaming format based on Adobe Flash Media Server's RTMP protocol. And what this thing does is takes a streaming endpoint, such as your iPhone. And you could, for example, let's say, if you go to Facebook, and they also have a similar thing now these days. Let's go to a CloudGenius page. And in that page, you can actually set up videos and say, go live video create. Not here. I think there is another place to go where you can publish live videos. Where are that? Where is that video library? Yeah, there, live. So here I can actually publish a live video feed on a business page, and they'll give you a streaming server URL. So by the way, this has a streaming server URL like that. And so you will create that location where you will stream it to. And you will also get this key that I am going to copy. I'm going to destroy the key momentarily, but this is the key that I need to provide. And that line number 1 is the address which I need to stream to. And now I have a place to send my streaming video to. Now, what do I need to use in my hand to actually make the streaming happen? For that, we have the iPhone, and there is an app for that called Facebook, which has a button for Facebook Live that you probably seen or done, you probably done it already. And so you just use the Facebook Live, and these are the people streaming live videos right now. And you can probably see what Obama is doing here. He does quite a bit of streaming. And so random people, I mean, in random companies just stream whatever they feel like, anytime they feel like. Even news companies are doing it. And so like that, you can actually, you know, I don't want to actually play a stream, but people are using their phone devices to stream out. That's one way to do it. If you are doing it professionally, what I would suggest is to use this software, open source. It's called Open Broadcaster Project, which has this Open Broadcaster software, which you can download for Windows or Mac or whatever, and then run it. And that software requires these links. And you give that software these links and the key here, and then you start streaming your webcam or your professional camera like I have here, or any other thing, like maybe I can stream this whole thing on a Facebook video, and everybody in the world can just watch it, that me talking. And that is how you actually stream, and Facebook makes it easy, and so does many other companies, like even YouTube will do the same thing and allow you to stream live, like here and here, and there is a RTMP stream like that, and a stream name key. This key is to be provided to that link. So pretty similar to that you have for YouTube, and another key. And that's how you will send a stream to YouTube, and you can do YouTube Live that will show up on your channel like this, and it starts streaming. Similarly, there are tons and tons of streaming solutions that you need to build yourself primarily. That Twitch TV, God knows how many streaming companies exist, and many of them actually let you do for free, like Facebook Live and YouTube, as you heard me say. But this software that I'm talking about, Open Broadcasting Studio, lets you connect to any streaming destination, like this one, for example, or this one as the YouTube example, or your own web distribution, which is something like, I'm going to cancel this one and say discard. And so like this CloudFront endpoint distribution, you get started. And here you will also get the same thing, basically create a RTMP distribution that will allow you to do a real-time streaming or a streaming from a ready-made file. You can do both scenarios. The scenarios are, you can either have a person hold a camera. I don't know how to draw a camera, but yeah, imagine this is a camera, and they're looking at some scene, and they're connecting this wire to a computer, and that computer then runs the Open Broadcasting software, and it connects to that streaming endpoint. And that endpoint you'll also provide with a key, and that key will connect to the streaming endpoint, which can be, your AWS CDN solution. It can be your Facebook Live, YouTube Live, God knows what. Commercial companies provide that service. Microsoft Azure also provides you a streaming video endpoint that you just want to make use of. And so all you really need to do professional video streaming on the internet for public audiences or for paid audiences is to have a camera and a computer running OBS. That's the basic requirement. OBS is open source, camera is cheap, and computer you already have. And you need internet access, and you need to have an endpoint where you can stream to. AWS will allow you, Azure will allow you to create your own custom endpoints, create your permission structure, licensing, ticketing, commercial events. All those things can be done very effectively. If you want to go public for free, just go to Facebook Live as one example, YouTube Live another example, and there are more. There are more examples that you can actually go to for free, and that's how you stream on the cloud. These days it is efficient and really cheap, really affordable. On the Azure side, I think the solution is called, let me find the name for it. On the Azure cloud, they have a name of, let me just log in. What's the name? Cannot remember it. Microsoft Media Services or something like that. They have a name for it. So I am logging in, and the wrong account. Sign out. Sign in. Other account. Oh, it's such a convoluted method I have of logging in. It's so hard for me. Microsoft, where are you? There. And here is the code number I want. Back here to this site and submit. So it should let me into the Azure cloud, which is where I will be able to show you the point where you can create your own streaming endpoints, use Azure services such as media servers. So I have no media services. I can just click create a media service account and quick create and choose a name for it and put a region wherever I want to go and use a storage account, give it a name, and it creates a media service. And that's all it takes. It will automatically give you everything it needs. And by the way, here is the credit I was talking about, the every month credit available to MSDN subscribers, which is getting wasted, as you can see. And I have 15 days remaining, and I still have $117 that I cannot use because there is nothing to do here, unfortunately. But that's my gripe. So I'll stop over, just stop discussing that. It's of no use to you. So the point that I was basically concluding on is these cloud companies, and by the way, Google also does the same thing. They will also do a free version, YouTube version, and they have a commercially controlled version in the Google Cloud for you if you want to use that, and enable your own streaming endpoint and a key and use open source software to stream out. There are some commercial software also that you may have heard of called Adobe Flash Media Server, actually Live Encoder. And so this software is free, actually. It is a commercial product, but free. And this does the same thing, like I mentioned in the Open Broadcasting Studio. You install this and connect your camera, and off we go. It will also receive from you, expect those two strings, which is a endpoint string and a key, and then you start streaming. That's how streaming actually works in real life. You can also stream files pre-recorded. And your pre-recorded files need to sit in a bucket somewhere and then stream, as opposed to live from a camera or an iPhone or a camera like this. Why can I not draw camera properly and stream? And so live streaming, pre-recorded on-demand streaming, both of them are possible very, very effortlessly these days, thanks to Open Broadcasting Studio, OBS, open source. And it works better than most other things that I have seen. I am not using it right now because I'm using Zoom because we already have it. but this is going to be useful when I don't need to talk to you like face to face. I don't need that voice coming back. This is like one-to-many transmission. Whereas Zoom is a multi-party communication, so you can also ask me a question, you can share your screen, and you can also show me your face if you like. And so that's where Zoom comes into play. It's a multi-party collaboration, as opposed to this one is a one-to-many transmission. And so that's a different use case. I occasionally use this on cases where I'm doing a public broadcast or sessions that are not in a class, so open sessions for open to public. And those sessions show up on YouTube Live, Facebook Live, and my own endpoint. So the S3 endpoint and a CDN, CloudFront. That's what I use on multiple locations. You will see that it pops up somewhere in the website. There'll be a page open where I'm just talking and people listen and they chat on Slack chat. And that's not really a class. It's one-to-many discussion. So I have done that in the past. You can look it up. It should be on the site. Some links you can find if you're interested. There is an Ansible discussion, by the way, that you should actually see. So if you have been reading the DevOps material, you should have seen the Ansible content already. Like I know at least one of you has seen it, which is nice, but nobody else did. So the Ansible lesson is actually, the Ansible open public broadcast is actually a part of the lesson already. You should see if you want to see that lesson, you should, especially if you're interested in Ansible. Okay, back in here. So what our discussion regarding Netflix that we want to finish that portion and then think about the other aspects that we were doing. So I'm going to go back to the Netflix topic. I'm basically going to delete this. I'll just leave the page. That will do. This will go away. And back in here. So now we have a complete picture of what we were discussing here, all the way end to end. The user comes in, looks at the web servers, gets the picture, gets the experience, gets the information about the movie, and when the movie actually starts to play, the movie will play from a content delivery network like this and reach directly the user, and it will grab that content from a pre-recorded video stored in the bucket. And that video selection will happen depending on what device the user has in their hands right now at that point in time. If they are using an Apple TV, then the Apple TV corresponding file will get picked up from this location, from the bucket location. And then the CDN will transport the Apple TV version for them to be watching the Apple TV or the movie on that Apple TV device. Now, halfway through the movie, you're playing a movie. Let's say you're playing some video, well, some random movie. I'm just going to YouTube right now. So on the YouTube video, you're playing some video, let's say this one. And you're playing it like halfway through, like this. And then you think that you should walk out. And at this point, you want to go walk out and maybe walk your dog in the sun while watching this MKBHD. This person, by the way, is a famous YouTuber. So you want to watch this guy. He's on the Apple TV, and you want to halfway stop at 2 minutes 23 seconds into the video. You want to now stop on the Apple TV, or you're watching it on the Netflix on Apple TV, and now you want to start the same or resume the same watching experience all the way from 2 minutes 23 seconds into the video onwards. You want to start from here and not from here. And that information is something that you need to worry about, because Netflix needs to worry about that. Otherwise, users will not have any method of resuming from the point that they stopped watching at this point on Apple TV. It was the Apple TV at which they were watching. They stopped it at this time. And now on the iPhone, they walk out with the dog and they watch the remainder of the movie on the iPhone. Now, when they start the iPhone app, what needs to happen for the experience that we want to have, this continuity of experience, right? I will ask you these questions as to what do you think Netflix needs to do to make sure to not force this user who just switched from Apple TV over to iPhone What do you think Netflix needs to worry about and take into account in order for the user to experience continuity and not a reset? Don't want to reset all the way to beginning because that gets boring. That's not what we want. We want to get our users a much better experience than anybody else gives. And so we want to actually let them resume from the time they paused on the Apple TV beyond and not reset. That reset is boring. I want to now, seek into the video and I forgot what time it was. I don't keep track of these numbers, but Netflix needs to. So what do you think they need to do? Help me understand. Help me understand if the user watches Apple TV, 2 minutes, 23 seconds into the movie, and now walks away. iPhone. They still want to watch the movie. What do you think Netflix needs to do?
Well, they have to remember where they paused, right?
Yes, remember. What else? So remember the pointer, right? This reference pointer, remember that. That's a good thing to remember. And they need to keep track of what the user is doing at that time, right? So otherwise they will not be able to remember. So that point.
Also, what movie they were on.
Yes, which movie. So remember the pointer, remember the movie. What else? Remember who it was, the login, right? The person who logged in. Otherwise we have no idea. What else do we need to remember? Which device they used before and which device they want to use now. Mm-hmm. Right? The device type is important because you want to render the picture that fits this screen as opposed to this screen. So the device type.
So, Nilesh, the question I have is like, is it not in the buckets wherever the source coming from? Is it not already converted or transcoded for a target device and it's getting streamed, or is it while I'm watching in the background the raw source is getting transcoded and I'm able to watch?
Yeah. So the scenario will be like this. What Srini is really asking is, so I have this movie called Incredibles, right? And it's the raw file available to me. Then I have this Incredibles.iPhone file and Incredibles.Apple TV file. 3 files, for example, already in the bucket. Simple Storage Service has it. So I'm watching this movie 2 minutes and 23 seconds into it. Now the user says, no Apple TV anymore. I want to go iPhone. So it will seek into that file all the way up to this point and pick up this file already available and start streaming this file from here point onwards.
Oh.
Right?
Oh, I see. Mm-hmm. Mm-hmm.
That transition is transparent to you. You have no idea what's going on. Right?
So YouTube does that for me. Like YouTube remembers just on my login.
Yeah, everybody will do that, the same thing. In fact, this is the classic concept of a good user experience. You're basically providing continuity. Right? There is another, a little bit more complex example of this concept available already in the ecosystem, in the industry today. And it is called WhisperSync. Have you heard of this thing? If you know this, tell me you do. If you know it, you already know a great detail about it. Otherwise, you have no idea what I'm talking about. So let me just describe it to you. But if anybody knows about it, please say so. Okay, nobody does. Fine. Let me see the chat. No chats. Okay. So let's understand WhisperSync. What is this thing? Let's understand. So WhisperSync is basically a Kindle software feature. Kindle is the book that you read, or rather, Kindle is a device that you use to read books from Amazon, right? You know this. So the idea is keep the story going. When you cannot read, listen. When you cannot read, listen. When you cannot read, listen. What does that mean? It means that if you are in your home and reading a book, the book is, let's come up with this book. The book name is called Co-opetition. Or the goal book, right? These books that you're reading. The goal book or the Co-opetition book. You're reading these books. And you're reading up to page number 35. But now you want to drive because you want to go out to your workplace. And so you're reading the book, page 35, finished. And there's a bookmark that, you don't need to worry about bookmarks, actually. In WhisperSync, you don't have to worry about bookmarks. You just read. And then you shut the Kindle and you go to your car. And there you grab your Audible app, where you have the same book in the Audible app. And you just start the app and select the book. It will know that you have already read up to this point, and then start playing the audio from the point onwards going forward. And then you reach the workplace and you have listened to the audio already up to whatever time it was, like maybe 37 minutes. It will translate that automatically and keep track of what you have listened to already all the way through here, starting from page 35 onwards. The corresponding point in audio time frame would be, say, minute number 13. So minute number 13 through minute number 37, you listen to the book in audio format as you drive, which basically is equivalent approximately to, say, page number 179. I'm just making these numbers up. And so at this point, when you go back to the office and you want to now read the book again, as opposed to listening to it, you can read. And it will show you this page 179 and tell you that you have already listened to these other pages up to 178. And that is what WhisperSync is. It is implemented by Amazon like this. You read, you listen. You listen, you read. And it synchronizes. When you cannot read, listen. When you cannot listen, read. Keep the story going. WhisperSync. That's the feature. Now tell me, how will you implement it?
Is that Audible feature or a Kindle feature? WhisperSync feature, right?
Both feature. It is a part of both. It is, Audible is a Amazon company.
I see.
Audible is an
so that's built in.
Yeah.
I see. That's built into the Kindle software, right?
It is built into the Audible software also.
Okay.
So this feature, how will you implement? How will you actually put things in place to have the book readable, audible together and synchronized? And the user experience is what I just described to you. So what do you think is needed in the backend on the cloud side for this experience to actually succeed? Like, we want WhisperSync. That's a good name for it. And so it's quietly synchronizing your position in the flow of the story and remembering the point in time at which you are in the page numbers as well as time sequence in the Audible book. And keeps track of it across 2 different apps, 2 different subscriptions, as long as you have the book available both in legible form, readable form, as well as audible form. The only drawback here currently is it's an economic choice that Amazon has decided, is that they make you buy the book twice. And that hurts. I mean, I don't like it. But from a technical implementation perspective, I have seen this experience. It is actually pretty darn good. If you buy the book both in the both in the Audible app as well as the Kindle app, that is double the cost mostly. If you buy some book, for example, and so here, shop Kindle books with audio. And so here you have this Leo Tolstoy book that you can get for Kindle for 99 cents and get the Audible version for $22. And so that's the hard part. And they will give me 3 months of free trial, but that's not what I'm interested. What I'm really interested in is the experience that I want to be able to enjoy, which is to be able to have a book that I'm reading automatically synchronized with my position with the Audible version of the book. And it's the same book that you basically see that it streamlines your experience of listening versus reading, and it is implemented by Amazon already. They have chosen to charge you twice, one for this and whatever that number was for the Audible book. And that's the difference in pricing, but that's their choice. So this is the Kindle version and the other version. Now you have to pay this money twice, once here, once here. But then once you do, you have this experience. Now, eventually, I think Amazon will actually make that subscription common between Kindle and Audible, and eventually merge the apps. That might happen. I don't know. Eventually, it might happen. But when it does, maybe the pricing of buying it twice will go away. Maybe this concept of a book, which is read-only book, can also automatically become an Audible book. And if you buy this, you get this, and you buy this, you get that. That might happen eventually. But for right now, the pricing structure is you have to buy these two separately. And if you do, then this experience enables. But my question to you is not about pricing, but about how would you enable this? Like, what does it take to make this happen? On two different apps. There is a Kindle app and there is an Audible app. There's an app for that, an app for that. There is a service for that in the cloud, and there is a service for this in the cloud. And you have content providers that give you book content that goes here, and those same content providers have a license to create Audible content that goes here. And there's this service, there's this service. And then there is a Kindle app and an Audible app. So help me understand, what would it take to enable such a thing of what they call WhisperSync? What does it need to have the book author, like Shakespeare comes here, Shakespeare, and he says, I have a book. And so you can either read the book or listen to the book, and I'll sell you here as well as here. And so I will give you the source. This is the source. And the users are here and here. This one wants to listen to audible fashion. This one wants to read. And so my questions really are about implementation, or rather not just implementation, but about how would you think about things needed to make this successful? What do you need? Like, what are the building blocks that you need to make it happen? That's the question I'm asking. So I'm asking you to think. I know you may not know because you never heard of WhisperSync before, and that is okay. But that's not the point. The point is, I want you to think and tell me at least a few things as to what do you think will it take to implement, or rather think about what would it take to implement such a thing to make it possible. What are the characteristics we need to capture, and how will we make these in place? How will we share services, share data among services, like this service and this service? So that's what I'm really looking to hear from you, your thoughts. Anybody?
So when you're reading a Kindle book, so there, you are already logged in and your credentials are with Amazon. So Kindle service will make a pointer or make a reference on where you are and what mode you are doing this reading, either listening or reading, on what format or what device. And then so when you stop at page 13 or page 19 and you get onto your car and hop onto Audible. So probably you'll still log into your account. So it has a reference to where it stopped earlier, and now switch the gears to Audible, like, because they're all stored in a common database.
Yeah, they are not common database. That's one of the things that you have to actually transport the information among services. So what you're really telling me, there is a couple of important things right now, which is the very first thing is you need to make sure that the login between this service and the login between that service needs to be synchronized. You need to know who's who. That's first thing. You just said that. The second thing you just told me is that a mapping between text to time in the flow of the book in terms of how many characters, words, sentences, paragraphs, pages. Pages is kind of irrelevant, right? If you look at iBooks as an example, as a proxy, so you have this book that I'm going to just open up, see if I can open up, or Getting to Yes, the book I said, Getting to Yes, right? I mentioned this book. And so here, you see that the book I'm on page number 32. However, if I just change the font size to a really, really big one, or rather, really big one, then the paging really becomes very different, right? It is not the page number that is important, but the amount of text or characters into what I have read, amount of characters that I have read through. And that has to map to the time that will play through in the book. So it has this mapping between text position in the text sequence of the book and the time sequence of the Audible book. That mapping is needed. And this mapping is a laborious task, really, really laborious. And somebody has to do it, right? Somebody has to map out the time on a Audible file, which is not MP3 by the way, I'm just saying MP3, and the character sequence in the text file corresponding to the book. That number of characters in how many text, minute number 1, minute number 2, minute number 3, how many characters here, 673 characters, 12,005 characters, like that. This mapping has to be made on a minute-by-minute basis, or maybe half a minute basis, depending on what resolution you want to go with. And that mapping is a laborious work. It's intensive work. It has to be done by a person, right? It has to be done by a person, otherwise somebody has to speak this book, right? This time an MP3 file is a spoken book. Some person has to speak it. The machine speaking is okay, but it doesn't sound as good as you want it to be read by a professional orator, right? A person who can speak nicely, professionally, and read out a book like a professional book reader, you cannot do it on a machine basis. Although technically it is possible to convert something like a CD, have you listen to a CD can speak out, but that becomes unnatural. You want a person who is a professional orator to speak and read the book, and that requires a human being for a good experience on your ear. Otherwise, you will say, you know, what's this CD? She doesn't know how to talk. She's more like a robot, and all those issues are still existing. You know, we don't have a perfect solution for text. So this person is involved, and that is a laborious task. Some books already exist, and so if you have a new person, a new book being created in the Audible format, it is relatively easy. You can just tell the person, hey, can you please, and can you please stop the noise in the background, please? If you can mute, that would be awesome. There is some noise going. So what I was saying is, if you can ask the new recorder person to just make note of what point in time which this maps to, that mapping is possible. Otherwise, you run into this problem of where did that whisper sync go? Okay, so whisper sync. The idea is in this location, you will find that not all books are actually ready for audio. So shop Kindle books with audio. So only these collection of books are available in that fashion. Not every book, by the way. And so these are the books for which the mapping has already been done. And in this example, if you go here, they are giving you a free audio book if you buy the David Copperfield illustrated book itself. So this Kindle book, if you buy, you get a free audio book. So that they're starting towards this idea of what I would call convergence, as you saw in the example. But not all books that you see here are actually ready with what I would like to have, that mapping between time and character sequence synchronized. This mapping is expensive and is laborious. And it has to be done by a person, otherwise the sound doesn't come across nice and you don't enjoy it. So what's the point? That's the hard challenge in here. It has to be manually done by a professional, which makes it expensive. That's why audiobooks are expensive. Now, having said, the other thing that we need to worry about is to somehow handshake between this service and this service every time there is a pause. Every time you say that, you're reading a book and then you suddenly leave the Kindle aside, you don't need to shut it down. You just leave it aside and just ignore it. That may constitute a pause, because you don't have to actively pause reading a book. You just set aside the device, the Kindle, and then it is considered to be treated as paused if you don't touch it or don't hold it or don't move it around or don't flip pages. Then it is considered a pause. Whereas in the case of audio, you have to actually press the pause button for the audio to pause. So there's a difference in how you pause, and you have to actually detect whether the book reading has paused. And there is some heuristics you need to put in place to understand when the person may have actually paused. And when the person pauses reading the book, you can presume that he has or she has paused. And at that time, you need to automatically send a handshake back to the other service. Looks like this guy who logged in, has paused the book at that point in time. So you just be aware. Yeah, I'm just saying. I'm just sending you that notification that the person seems to have paused at that point in time, at that point in character sequence on the book, because the person is not flipping pages, or maybe the Kindle is set aside. And now Audible will know. And then when you go to the car and start driving, and then you start your Audible app, then it connects to the Audible service, and it will figure out that you seem to have paused already. So I know the last time you were at that page, I know. So let me just tell you that I'm on that page, or you were on that page before. So I'm going to play back from that point onwards. Is that what you want to do? And the default answer is yes. So that's what will happen. It will start playing from that point onwards. And when the user on the Audible device pauses again, and this time is an affirmative pause button, because he or she paused it, that time this Audible service has to send that signal response back to the other service, just letting you know the person has stopped or paused playing, and I want you to keep track of where he or she was in the book side. So when that person opens up the Kindle again, when he reaches the office, that you can automatically show that person, you seem to have already listened up to this page. Do you want to resume from that point forward, or you want to go back to some other place? And so you let people jump around, but at least give them a sensible choice that you already have listened to. Do you want to skip ahead to that point in the book right now? The default answer is very likely yes. And that's the handshake that is needed across two logged in users on two different services. The Kindle logged in user and the Audible logged in user needs to be the same person. So that login authentication needs to be made. The two services need to handshake, and the mapping between a text book and a audio book in terms of characters and time has to be synchronized manually. That mapping needs to store somewhere common between these two services, so they can actually access that on their own whenever they need to, whenever they feel that need to actually look up that information, when there is a need for them to play forward from a given point in time. That information can be obtained centrally from that location, and those two services can automatically, intelligently start playing from that point onwards. That's the key thing to think about, which takes us back to our Netflix discussion, which is this: when the user was playing on the Apple TV, he or she, when they move this continuity of experience on the iPhone, will seek through into the 2 minute 23 seconds into the video, and play forward from that point onwards on the iPhone. And when it pauses again at some time, maybe not, but maybe if it does, and the user comes back home, this time they're in the game room and they want to run it on the Xbox, and that is not this file, by the way, but a different file. So I should draw it another direction, maybe here, Xbox, and this Xbox will actually play the Incredibles movie in the Xbox format, all the way seeking through up to this point, and then play from here onwards. And the movie continues to play Apple TV, iPhone, Xbox, like that. I think I want to be mindful of the time, and we are approaching that 8 o'clock time. I know I keep talking and I just overshoot, and that's not a good thing. And so I want to take a pause at this moment and listen for any questions you have. There are lots and lots of little details that you need to think through if you construct a service as comprehensive as Netflix, as you know. And my question to you primarily is, do you want to go deeper as much as you want me to, or you want to cover a variety of cases of different types and then understand some of the simpler examples, which are also there, by the way, to go through? Or basically, I'm looking for feedback. So what do you think? Do you want to go further deeper in Netflix and understand it even more, or maybe take a different case next time? That's the question. We already have spent 2 days just on Netflix, by the way. It is that intense. Actually, 1.5 days. Right? So that's the question I have.
So Netflix seems to be a great case study, right, with the cloud capabilities.
Yes. So I think what I want to be able to do is give you a good flavor of different types of services that you can actually see in real life, and some of the implementation that you will see in cloud services like Amazon and Microsoft. These guys have done a tremendous amount of work, these companies, in producing charts like these to help people understand how will Amazon implement a media sharing of media and content sharing solution on their own infrastructure. So these are actually reference examples made by Amazon to help people understand what would it take to enable media sharing on Amazon Cloud. This is a marketing material for them. For me, it is an educational tool for me to help you understand that it is not really necessary to use these cloud services specific to Amazon. But I want to call out that none of these things that I actually mentioned are specific to Amazon. In fact, you can use every single component like Route 53, like Cloudflare, like Google DNS, like other companies' DNS. It's a generic solution exists. Like Elastic Load Balancer, you can use other companies' load balancer, or you can use HA Proxy or Nginx. Any of these tools can be used in the open source to construct your own load balancer if you like. Web servers are web servers. They're basically Linux boxes, or maybe sometimes Windows boxes, depending on what you want to run. Data store is a data store. It doesn't really matter which type of data you want to store. Depending on that, you will actually select the store for the data, whether it is a database like MySQL, PostgreSQL, or other commercially available databases such as Microsoft, Oracle, those names. And so they will all be helping you storing data. But the idea is that all these elements like S3, there is an open source equivalent of that in your OpenStack. There are other companies that provide solutions like this. Similarly, you have here auto scaling is common across all cloud providers. Simple queuing service is open source solution for that. for queuing. Actually, there are tons and tons of solutions available for queuing software that you can run on a separate box that will make sure that your queue is managed appropriately. You don't need to have this simple queue service, but that's the service implementation that you have here already from Amazon. And Spot instances, yes, these are available on many clouds. This name Spot instance is, and in fact, the machines that we are dealing with, they call them instances. And that's just the Amazon representation. But the fact remains that this representation, this illustration of the architectural diagram actually is pretty darn useful. However, it has the marketing tone of Amazon. So it's a branded material, right? It is basically Amazon's way of doing things. You can find a very similar implementation in, like I just described to you, or other cloud companies. They have not created material like this, except Microsoft has recently created. Let me point out that to you. Azure architecture. They have recently been starting a ton of architectural design patterns on the Azure cloud. And there are some patterns defined. There is also a list of charts available that you can get from, where is that? Here, maybe? Yeah. So I'm going to paste a link for you. And that is where you will find the Microsoft examples, and this aws.amazon.com/architecture is where you will find the Amazon example. And so every cloud company that has the money and the capability to actually create these illustrations for themselves are doing it. Amazon started doing it first. And don't mistake them to be marketing, and don't mistake them to be a cloud company specific thing. You can actually learn from it and make it agnostic to any cloud that you feel like. It doesn't need to be this particular company. But I must say that they are very nicely done drawings, very nicely drawn out architectural diagrams, and that is why I like them. For the merit of it, I use them, because I think they're very, very nicely illustrated, allows me to explain a point across very comfortably. And that is why I actually like both this as well as the Microsoft representation. If you are a Windows user, and if you are using Visio, if you have a Visio access already, then you should use this other tool that Microsoft has now released for Windows users, and that is called, hold on, 3D Visio Azure. Yeah, here maybe. Yeah, so here is the template for 3D illustrations on Azure, on Visio, if you have Visio. If you do not have Visio and you're a Macintosh user, then there are these apps that I use, which is called Omni. Omni.com, omnigroup.com. And this company will give you apps such as OmniGrapho to create beautiful illustrations for any cloud. So there is a Grapheltopia, maybe. Yeah, Grapheltopia will give you nicely done stencils shared by the community, and sometimes commercial artists that will give you access to. And so you can, $24 a year, get access to decent illustrations. That's what I use today. You can draw it on your own if you like. If you're an artist, like I am not, you see me draw a camera and I suck. And so this is my camera, I guess. This is how I would draw. But yeah, so I'm bad at drawing, but you can buy these licenses and then use them. That's the illustration if you're interested. I know some of you are interested in the Mac version is this. The Visio version, the Visio, if you have Visio, that thing itself, not Visio.com, I think. Oh, it is Visio.com. So Visio.com is now owned by Microsoft, and yes, you can use 3D illustrations like shown in this example. And so play along with that if you're interested. If you have Visio, the thing is free. If you have a Mac, you need to pay money to these guys. If you are really, really interested in open source, there is this thing called Inkscape. That will help you illustrate some three-dimensional drawings and that is open source. So you can use Inkscape to draw, but you need a device like what I'm carrying right now. And you can use this tool. It's possible to do similar demonstrations by using AWS or any other cloud company. Yes, Azure. Azure examples I just showed you, like the link above. There's a 3D template there. 3D blueprint Visio template, that one, this link. 3D blueprint template, you can use it, totally. And if you have Visio, totally get it. Totally get this template and use it. You can draw. The illustrations look slightly different. They look Microsoft-y as opposed to Amazon-y. So this is how they will look like in Visio. They look like Microsoft.
I have a question.
Yes.
If you wanted to deploy this architecture in the cloud, what do you need to provide? Like if you wanted to deploy this in the cloud, like
provide money.
Okay, so all you have to provide is money, and everything else is provided by.
And code. You need to provide all these things.
Okay.
Yeah, you need to provide money, provide design, provide the code that you will have these services run on, and then it will work. And you need to.
You'll be having to configure it yourself, right? Or
yes. That is why cloud is so cheap, because they don't do anything. All they give you is machines, or sometimes some services. So they give you a service that may be a differently priced item. So if you use a service, it can be cheaper to begin with, but on a long-term basis, it can become expensive. Right? If you're paying as you go along, CDN, as you saw my usage, is very, very cheap. It is actually free for me, practically speaking. Maybe a couple of cents once a month. But imagine if I start serving videos, large files, to everybody, I will get hit with a bill. I don't want to spend money, so I have found another way. I actually use YouTube. You've seen me putting videos on YouTube, right? At this Cloud Genius site, YouTube videos are on YouTube. Let's go see some of them. This video is actually on YouTube. You see that? So I don't waste money on high bandwidth assets. I just give it to YouTube and let people watch it on YouTube because I don't want to waste money. And I don't make money on giving videos as such, because the way I make money is through places like you. You give me money, right? I mean, you or your company, one of those. But that's how I make money. And so the services that these companies provide, like YouTube is free, but you can actually host your own video streaming solution, put a media repository bucket in here, put a content delivery network, and get the URL from there. It is actually pretty darn simple. And you can see it in example, just like these examples. There will be a video there already in my bucket. I just need to go and find it. So I will go to this bucket and find a video if I have any. There should be some video somewhere here, maybe. Here. Yeah, I forgot where I kept that video because I don't use it. No, I forgot. There is some video somewhere, but then I don't use. Oh, there it is. There is a dedicated video bucket called Cloud Genius Videos, and here is the link for it. So I'm going to copy that link, open it up, and here is a video. So this is how I can serve a video to anybody on the internet using my own bucket. I just place the item in the bucket, put a CDN on top, start serving, and I control it totally. and I can upload it through my own infrastructure through S3, or rather through S3 right here. And I can permit for anybody to view, and that becomes a way of me running my own content streamed on the internet, happening right now. Let's see, any more questions? So what I will do, at least for a few more hours, is to go through a variety of examples and give you a flavor of a variety of different implementations in the context of a couple of clouds, such as Amazon or Microsoft, and change the topic a little bit, not beat down on the video rendition, but a little bit more variety of it. Maybe do some more videos in a different fashion, and think about what would it take to implement these things, and then take some examples on actual implementation. Play with some Docker to see multi-layered architecture and things of that nature. We'll do some of these as we go along, right? Cool. So next time we are meeting on the 18th, right? Correct. Yes. 18th is the next class, which is Monday. So I'll see you at 5 o'clock.
Thank you. Good night,
Bye.
everyone.
Bye-bye.
And Nilesh, thank you.
Bye.
Bye-bye.
Thank you. Bye.
Bye-bye.